Let's take a look at another two-stage experiment. In this particular experiment, we have 4 different colored marbles placed in a bag. The bag is shook up, and you reach into the bag and pull out a marble. Then you reach into the bag a second time without replacing the first marble and choose another marble. We know that there will be 12 outcomes for the two dependent events combined. Why is that? If there are 4 marbles in the first event to be chosen from, and we do not replace the first marble picked out, that means that in the second draw there will only be 3 marbles to choose from. Therefore, there are only 12 outcomes. Let's list the sample space for this experiment. As you can see, the sample space is shown here. Using this sample space, let's determine the probabilities that are listed here below. What is the probability that I will draw out of the bag a yellow marble first, followed by a white one? Well, of course, we know that that can't happen because there are no white marbles in the bag. So this answer obviously has to be 0. How about red followed by green? Well, if you look at our sample space listing, red-green is right here. That is one of our outcomes out of the total of 12. How about green-green? Well, is it possible to get green-green? Since if you draw a green marble first, there will no longer be a green marble in the bag for the second draw, you know the outcome green-green cannot happen. So it also must be 0. How about the probability of drawing the same color? If we draw, for example, a blue marble first, can I get a blue marble in the second draw? If I've already taken the only blue marble out, obviously I cannot. So the answer to this one is also a probability of 0. Let's take a look at these two scenarios. How about if I draw any color followed by red? Well, let's look at our sample space to determine this answer. Notice we have up here blue-red, we have green-red, and we have yellow-red. That is 3 possible outcomes out of a total of what? 12. So there is a 3/12 probability that that can happen. How about different colors? What is the probability of picking 2 different colored marbles? Well, let's look at our sample space again. You can see that every outcome shown in our sample space represents different colors. Since there are 12 outcomes shown, that means there is a 100% probability that we will get different colors, or 12 ways out of 12. Now let's do what we did last time. So let's take a look once at a method we can use to determine these probabilities using the individual outcomes, individual probabilities, and multiplying them together. Will this work in this scenario? The probability of pulling a yellow marble in the first draw is 1 out of 4. The probability of picking a white one is 0 out of 3 to get, and if I multiply those together, as I did recently, I will get the answer 0, which is correct. How about red followed by green? Well, in the first event, a red marble has a 1/4 probability of being drawn individually. A green marble has the potential of being drawn on 1 out of 3 times. And if I multiply those together, I get 1/12, which is what I expected to obtain. How about green-green? Well, let's see. Can I get green-green? Well, In the first event, there's one way out of 4 to get a green one. But unfortunately, there are no ways out of 3 to get a second green one, since the green marble has been pulled. Therefore, the answer is 0. And almost identically, for the same color, we have the same issues. There are 4 out of 4 ways to pull a marble of a particular color in the first draw. However, in the second draw, there are 0 ways out of 3 to get that color again. So if I multiply those together, the answer is 0. How about any color followed by red? Well, we're going to have to look at this a little bit differently. Let's look at the second draw. There is 1 way out of 3 in the second draw to get a red marble when a first marble is drawn out. There are only 3 ways out of 4 to get a marble that meets this criteria of any color to be able to have a red one in the second draw. Notice, again, I get 3/12. And finally, how about different colors? Well, in the first draw, there are 4 ways out of 4 to pull a color, and there are how many ways left over for the second draw? Well, there are 3 marbles left and 3 different ways that they will be a different color, which of course gives us 12 out of 12. So our multiplication method appears to work. So this leads us to the counting principle of probability. If a first event A has a probability of W over M of happening, and is followed by a second event B with a probability of R over X of happening, then the 2 events combined will have a probability of W over M times R over X. This rule holds true even if there are more than 2 events. Let's take a look at this experiment. Picking a marble 3 times out of this bag of 9 marbles while not replacing each marble drawn each time. The probability of drawing blue, blue, green. What is that probability? Well, blue, there are 3 blue marbles out of a total of 9. So, therefore, in the first event of 9, to choose the blue marble. In the second event, there are only 2 blue marbles left out of a total of how many marbles in the bag? Well, only 8, so there are 2 ways out of 8 that it can happen in the second event. Okay? How about drawing green in the third event? Well, there are 2 green ones, but we're down to only 7 marbles in the bag. So it's 2 out of 7, and therefore our probability of getting the outcome blue, blue, green is 3 9s times 2 8s times 2 7s, or 12 ways out of 504. How about green, green, yellow? All right. The probability of pulling a green one in the first event will be 2 out of 9. The probability of pulling a green one in the second event is 1 out of 8. The probability of pulling a yellow one in the third event is 2 out of 7. And the answer here will be 4 ways out of 504. How about blue, blue, blue? Well, let's see. Blue, there will be 3 ways out of 9 for the first event, 2 ways out of 8 in the second event, 1 way out of 7 in the third event, for a grand total of 6 ways out of 504. How about red, red, red? Well, let's see. There are 2 ways out of 9 in the first event, one way out of 8 in the second event because there's only one red marble left out of 8 marbles left in the bag, followed by 0 ways out of 7 because there are no red marbles left. So it absolutely cannot happen. So having discussed these properties of probability and having looked at several examples, let's return to talking about the probability of coincidences. There are many more complicated situations and circumstances which enter in determining the probability of the various several-stage random experiments. For now, we have at least covered the basics we need to be able to look at the probabilities of the crazy and surprising coincidences we encounter in life, similar to the birthday question brought up earlier. Before we actually solve that birthday question, let's look at some problems which will lead us down the correct path of understanding to tackle such probability problems.